Welcome back everyone for part 3 now of the 4.3 notes where we're talking about logarithmic functions. We're finally going to introduce, for reals this time, a few of the properties of logs that have been alluded to previously, where we have, in this case, the first 4 that we're going to see. Some of them, we will learn later, are kind of similar or else derived from each other. But we will just enumerate them this way, that we will have, at this point, 4 different ones. We will use log base b. Whenever this b is here, it means it doesn't matter what the base is. This will apply for every different kind of base. And this property, what it says is that if you take the log of 1, it doesn't matter the base, you will get 0 as an answer. And so we will, after we go over these, we will try some of these problems where we will use these properties in order to simplify some expressions. We also have another fact, and this is going back to this idea that log and the exponential functions, they are inverses for one another. And so if you plug in, for example, b to the x power into the log base b, it's like composing the function with the inverse, and so you will always get x as the answer. What that means, in other words, is that if the base of the log and the base of whatever is in the argument there are the same, then the exponent of the argument is the answer. I hope that that makes more sense. We will have also, if you just take log base b of b, for example, where here we understand that b is the same as b to the first power, then of course you should get 1 as an answer because we're supposed to get the exponent as the answer. And so that's what I mean, that some of these properties are related to each other or that you can derive one property from another. Here, if we just let x be 1, and then it'd go b to the first power, and it will equal 1. And so that's what we have. We're just calling it a different property for now. And then we have also this kind of a thing, where if we put as the exponent log base b of x, here this is another situation where we're composing the function with the inverse, but we're composing it this way. We're having where the function is b to the x, we have the inverse is going log base b of x, and then we're composing in where we're going f of f inverse this time. So f of f inverse of x, this is going to go b raised to some power over here because that's what f does. It goes b raised to some power, and the power that goes in there is going to be f inverse, which is log base b of x. But we know that if we compose the function with the inverse, we're supposed to get x, and so this will equal x. And that is the property that we're using right here. So now, why don't we get going on some of these expressions that we'd like to simplify. We have log base 19 of 19. And so that's this property over here. Why don't I just number these properties? 1, 2, 3, and then 4. We will go like this so I can refer to the property by number. This would be like the third property where we have the log and the base of the log and the argument, they have the same base. And so the answer is the exponent. Of course, this goes 19 to the first power, so it's just 1. We have also a question like number 22, because you'll see that 20 and 21, they're the same as 19. But here, number 22, we're taking log base 273 of 1. But of course, if you remember what goes on with this property, property number 1, log with whatever base, it doesn't matter. So the 273, don't let it trip you up. If you take log of 1, you're going to get 0. So that one's just a 0. What about, for example, number 24? We have a nice problem over here. Log base 30 of 30 to the 10th power. And since here the base of the log and the base of the argument, they match up, they're the same, then the answer would just be whatever the exponent is. Oops, sorry about that one. The answer will just be whatever exponent is on there, so it's 10. And then we have, what about, for example, ln of e to the, I want to put parentheses around this one, e to the negative 12 power, just to be sure that we realize ln is a function. You know, you plug something into functions like this. A lot of times people want to say maybe like ln times e to something. It's not times, it's a function, and we're plugging in a value into a function. And so this one, the base, because of course this goes log base e of e to negative 12, the base matches up with the base of the argument there. So the answer would just be whatever the exponent is. And then we have also a problem like this, where it goes 10 raised to the power that goes log of 14. And of course log of 14 goes log base 10 of 14, that's the meaning of log. And we have the same situation where the base of the exponent and the base of the log, they match up. And so the answer is just 14. It's like this whole rigmarole we went through with composing the function with its inverse. So that is how these problems will work. We will see more varied types of applications for this later, and we will see some more properties. These were just the basic properties. There are some more properties to come, properties that will be very useful for us when we're solving actual logarithmic equations. But I hope this video was helpful for you guys, and I will catch you in the next one.